Ladies and gentlemen, do come in, take your seats. I know a few people have gone off for a breath of fresh air, but they have made a mistake because
miss out.
because I promise you, this is definitely worth your time, even after a long day. And afterwards, of course, you're going to be rewarded in the best possible fashion with excessive amounts of chocolate in all possible forms. So it's my pleasure to move over to Christine Finlay and Peter Gibson, our chair people for tonight. And so without further ado, Christine, Peter, thank you for taking this on and introducing this special event.
Thank you very much, Mark. It's really my great pleasure to welcome you to this pre-dinner session entitled "Too Much of a Good Thing Can Be Wonderful." I agree. The use of chocolate in medicine, and then to sort of align the bad conscience, guilty conscience, with anti-reflux advice. So my name is Christine Finlay-Bissett. I'm from the University of Adelaide, and I'm co-chairing this session with my fellow countryman, Professor Peter Gibson from Monash University in Melbourne. I was wondering what specific expertise I bring to this session that makes me qualify as a chair. And the only thing really that I could think of is my love of good chocolate. I hope that is acceptable. So thank you, Mark, for your invitation. It's a great honor to be here. So it's a great pleasure to introduce Professor Thilo Hühn. I have not met Thilo personally before 5 minutes ago. So I'm very much looking forward to his talk. Thilo is head of the Center for Food Composition and Process Design at Zurich University of Applied Sciences. He describes himself as a food architect, inventor, developer, and implementer of regenerative technological processes in companies. And with his team, and in cooperation with partners from science and industry, they develop and implement novel solutions for the food world and provide the basis for the development of transformative and regenerative food processes. If this sounds a bit cryptic, you're in the right place, as Thilo is going to explain the practicalities of his approaches using chocolate as an example. And I should probably add, before I hand over to Thilo, this is really meant to be an entertaining session. So unlike in all the other sessions in the last few days, we're not planning to take questions at the end. We really want to listen to all the presenters. And Thilo says he usually doesn't talk for under an hour. So tonight he has got 20 minutes. So without further ado, over to you.
Thank you very much. Good evening.
Thank you.
Thanks a lot, Mark, for inviting me. It starts with a degustation of chocolate. Please pass it around. Grab one. It's 78% of dark chocolate from Peru. And please, this box is for this half, and this box is for don't cross the border. So, do you need any back? As mentioned, I see myself as a food architect, but sometimes I don't know really what I am. I'm socialized as a farmer in Germany on a little farm with wine. So I did first vocational training on enology and then studied it. And I grew a little bit up. And let's say I was formed as a small biologist. Very small biologist, so microbiologist in winemaking and aroma research, and this is my background. I think we should forget about the slides because 20 minutes is almost impossible. We do the degustation, and I will talk a little bit about what we observed. 35,000 years ago, that sounds good. 35,000 years ago or so, mankind invented such things, grinding with stones. And the Mayan and the Aztecian, they grind very fine. They use stones, put it over the fireplace, and use this wonderful fruit. No worries, Mark. This wonderful fruit with 30 to 50 beans in it. And here are the cocoa beans. If you grind it on a hot stone, let's say the temperature of the stone was around 60 degrees centigrade, the fat comes out. The fat content of in dry matter is around 55%, cocoa butter. And it sticks to the stone. You can try it. One of my students did some studies, and in his final presentation, he calculated that more than 70,000 times he turned the pistol in the motor in different ways. What do you think is the finest particle size you can reach it without punishing him? With something. What do you think is the finest particle size you can get using a motor?
You can get it very fine.
Very fine, yeah. How many micron do you think?
I don't know, but we make it.
Sure, you.
We make sauces.
Yeah. This is a good idea to do it in oil. Yeah? This is one of the secrets of our patented process. Yeah? 5 micron. Yeah? 5 micron. Yeah? And if you go to fine chocolate, the confiseurs. I'm no confiseur. Yeah? Don't trust me at all. I have no clue what I'm talking about. Yeah? They saying 20 micron is the minimum you have to reach, better lower than 10, around 5 micron, to have a fine chocolate. And you all know, you are in Switzerland now, and this is a Swiss invention by Mr. Lind, more than 100 years ago, almost 150 years. There's a story, he forgot to stop the conche over the weekend, and when he came back, he reached this really fine level of conched couverture, and after that the chocolate is made. So this people who already tasted the chocolate, what do you have to speed up a little bit, please. I see you are a little bit tired after this day. So I hope that everyone already tasted this chocolate. People call it dark chocolate. Usually dark chocolate is bitter and sour. Can you feel the bitterness? Only a little bit, huh? And it's not sour, because by doing the same as the Mayans, we stopped with the hot stone and the grinding. If you do that, the chocolate paste sticks on the stone. What did they do? They use water, and this is the reason why it's called choco for cocoa. Atl, water. Choco atl means cocoa with water. They use the water to make it soluble, get it from the stone, and they drink it. So we today do the same. We mill the cocoa beans, fermented but not roasted, only debacterized the surface. There are some organisms on the surface you don't want to eat. I think you are really familiar with that ones. Yeah? So you have to debacterize the cocoa nibs, and then we can mill it really down to the ground, adding water. This is the process applied here. And by doing so and doing a phase separation, we can put out around 80% mass by mass of the volatile acids, mainly acetic acid. And this is the reason why this dark chocolate doesn't taste so sour nor bitter, because the sour impact boosts the bitter impact. And sugar is really on top of the list. After nicotine, I thought alcohol will come, but sugar came. And this is one reason we can produce high cocoa containing chocolate with only a small amount of sugar. Perhaps you know that milk chocolate, and this is the next sample I want to share with you. Don't forget.
That's right. Thank you. One.
This is from Ghana. Yeah. Really, our process reflects the product quality from the beans, where they stem from, and so on. And Mark said that there are no questions allowed. But you can ask me later if you want for the process and so on. So when it comes to milk chocolate, usually, you know, there are products on the market. You can buy 500 grams of chocolate, not in Switzerland, 500 grams of chocolate for, let's say, around €2 with a content of more than 70% of sugar. The content of cocoa is only 11%, defatted cocoa powder. I wouldn't call it chocolate. I would call it Zuccolade or something like that. It's really problematic. Our invention leads to products like that with around 60% of cocoa. This is milk chocolate, but with way less sugar. So someone would taste that more or less as a dark chocolate. It's not a dark chocolate. It's milk chocolate with a high content of cocoa. And if you want to dive in the secret, let's say, of the process, the company is named Oro de Cacao because of the cocoa butter, which is, thank you, Christine, which is really golden. Yeah? The aroma components you will find here usually in white chocolate. It's only containing cocoa butter, but this cocoa butter usually is de-aromatized because they get the butter out of the cocoa beans at 230 degrees centigrade. And doing so, you generate some aroma substances which reminds you on burned rubber, so they have to deodorize it. Our cocoa butter, we run the process below 50 degrees centigrade, is really rich in original flavors. There's no addition of vanilla or something like that. There's no addition of anything except of a little bit soya lecithin or sunflower lecithin. They think they need it as an emulgator. But there's no aroma added in these chocolates. You already tasted. And here in the white one, you can really taste the aroma of the origin. Again, Peru. I like the Peru very much. Yeah? I brought, because Mark asked me for a tablet of 100% cocoa fruit for you. This will be served, if you want, as a dessert or for taking home, yeah, in after dinner or during dinner. There are 10 minutes left, so I can show you some slides. This is the fruit. On the trees, there are flowers and fruits at the same time. You have two harvesting seasons. One is around May, and another is around. You turned me off.
That's all right. That's good. Carry on.
So I reached the time limit. The cocoa plant is really specialized. Yeah? You have specialized cells for polyphenols and specialized cells for fat. The polyphenols are really important, as you know better than myself. Yeah? We have catechin and epicatechin in high concentrations because of the low processing temperature. There are some products like Acticoa from Barry Callebaut. They reached the claim in European Community for health claim. They were the first doing so. but they use the whole unfermented, unroasted beans to get there. And we get the polyphenols as a side product, let's say. We always talking about all streams are mainstream. Yeah, it's not a side product for us, but you can imagine from 1 ton of cocoa, we get around 100 kilograms of these dry extract. And there are these wonderful substances from the cocoa bean, which usually are thermally degraded. And you know, by condensation, you have larger molecules. The bioavailability is not so high, and the effect, but you asked better Mark or someone in the room about the impact. Yeah. What we developed in between, but this is not the topic this evening, is a cell culture chocolate. But you can Google it and find us. We developed strategies to use these cells and produce cell cultures in a tank, like it is already known. So specialized cell with special ingredients. Yeah, this is the content in fresh material. The interesting thing when it comes to these polyphenols, and this is why I call it exponential process, is that if you compare the price for the defatted cocoa powder with the price which is paid for the polyphenolic extract, it's 1 to 20 to 1 to 30. So you have really a good chance to have a value from the before not existing stream to a mainstream. So in the usually standard cocoa process, these components are destroyed. From a microbiological point of view, it's a disaster. These fermentations are really uncontrolled, and many working groups are doing their work on controlling these cultures. You see, this is really poor conditions with a lot of influence of insects and other animals, and they eat the cocoa beans and they do some biotransformation and let, you know that, we share that in common with biotransformation. What you can do is you can put a little bit the pulp away, and this is in this 100% cocoa chocolate you will get this evening. There is no sugar added, because sugar is in the pulp and some acids for sure, but there's no beet or other sugar added. It's from the pulp, and therefore it's 100% cocoa. You can't call it in Switzerland or in Europe chocolate, because chocolate has to have some sugar from beets or other sources, but not from the cocoa. Yeah, this is really rich in aroma too, this pulp. You will feel the chocolate. By the way, we were the first producing it in Wädenswil 2014. In between, some other companies commercialized it, but now we are, or the cacao is on the market with this new product. The process, you know, this is, a colleague of mine was traveling in South America and brought this picture of this photograph to me. These Mayan people, or these ancient people, they were really smart. Yeah? They understand way more than some of us today. And yeah, as I started, I had no clue about what's going on. They blew some. But this was the most important thing, having no clue, thinking the process from the very beginning. And they add air by blowing into it or mixing it. And by doing so, you know, you have a reaction between polyphenols, enzymes, proteins, and so on. And in the end, it's less bitter. Huh?
Trying to get it a little.
Now we have a little bit light show. This is the main instrument we are using. As I said, we are milling it down to the ground with water to particle size you can read and find in the patent or others. Very small, yeah. And then we go to this horizontal centrifuge. It's a 3-phase separation. You can have the water phase, which is transporting the acid out of the cocoa beans. Why acid? You know, they do fermentation. The main reason is to put the pulp away from the cocoa beans. And there you have first yeast, which produces out of the sugar some alcohol, and then acetic acid bacteria who produces from the alcohol acetic acid. So you can't prevent it. Yeah. If you want to do a fermentation, classical-wise, you have, let's say, a contamination with acetic acid, and the concentrations are really high. So let's say around 10 to 15 grams per kilogram fresh weight. And you know, in wine, if you find an odor of this acetic acid, it needs only 500 milligrams per liter to destroy all the beautiness of the complexity of the aroma. And the same happens with a little bit higher concentrations, but the same happens in chocolate too. So it's really a mess if you can't get rid of the acetic acid, what we managed. These were the first trials in our pilot. You know, our pilot was small, but if you want to use this technology, the smallest size of the machines are around 200 kilograms per hour. So it was not easy to do the experiments, but it was more easy to scale it up to a really factory. So this is the main investor. Some of you, perhaps from Switzerland, know him. The techno band Yellow, Dieter Meyer, invests in foodstuff. And at the end, we met years ago, and he decided to invest in it. Now we built a factory in Freienbach, which is close to the university. Private equity, so the university sold all the patents to the company. The capacity is around 5,000 tons a year. This is small for chocolate production. But it's not only chocolate production. I hope I showed you that there are many side streams. We have this polyphenolic extract. We have an aroma, which is from the natural cocoa bean. Yeah? I have it here with me. Around 10 to 15 liters per ton. The dry extract around 100 kilos per ton. The cocoa butter, it depends how you run the process, around 300, 350, 400 kilograms, and the rest is defatted powder. You have such a toolbox to combine it for chocolate or for other food products or for functional products or for cosmetics. Now we start to run and understand more the impact when it comes to health. Mark did some things, and we will continue hopefully with Anne-Christine too. So it's still a startup. They invested a lot, 70 million Swiss francs. I hope that it will work. You know, as an engineer and inventor, it's always nice if you have finally an application. This is, again, the technology we have to skip because only 20 minutes. This is the process. You can find some things on the net. These are the 4 main elements we produced out of cocoa. And you tasted the products which coming out. Why do I do so? And why do I stay at university? Because of these people, our students. This is really marvelous. You can start telling your story from the beginning. You all know that, and get new insights. And we developed some other processes, but this evening it's only for chocolate. Does it look nice? All natural. This is one important thing for me, coming from the processing of grapes. I really want to honor where it stems from, the cultivation, the plant, the vintage, and the processing. So there is no additive, sometimes a little bit of sugar, and they decided to add soya lecithin. I don't think so that this is necessary, but you know, I'm only one of the inventors. Huh? That's me, 2014, Mr. Meyer, Roland Laux, the co-inventor. We were traveling through Venezuela, and really I had no clue about chocolate processing, and one friend of mine, of us, put us in a chocolate factory in Santa Cruz, and Roland said to me, you can do something with your decanter technology, and you have heard about the story since then. Thank you very much.
Well, thanks very much, Thilo. We are running a bit chocolate, so I told you I'd get it in there somewhere. I think that the key things are for us, of course, as advisors of good health and what we should and shouldn't do. We need to know why it is good and why it is not good. Or is there too much? So the first talk about the chocolate as a medicine, the evidence base, is from Anne Kristen Meyer from the Klarerforschung Klarhospital.
You're doing so well. You're doing really well.
In Basel, in Switzerland. And Clara, I'm not going to, because we're running chocolate, I'm not going to give your CV out. But if you would like to tell us about it as a medicine.
Oh, no. Second one, sorry.
You need the previous one.
This one's got 5 versions open. I'm going to have to close that.
You mean, Mark, I had a bit of time for a couple of more jokes in there.
You definitely do. You got to fill this space. You've got to fill this space. Okay, here we go.
Fantastic.
Thank you very much.
So thank you very much for the introduction and welcome everybody to this special event. I'm very happy to be here today. I will talk about the regulation of appetite and I will present some results from our shocky study that we did together with Mark. So if you listen carefully to me within the next 20 minutes, you might get a secret tip on how to win the Nobel Prize. So, so I have to change a little bit here. Can you see the mouse?
You can see the mouse if you look at the screen. Look over your shoulder.
Yeah, I cannot see it. No.
No, you have to look at the screen.
Ah, okay, perfect. Good. So let's start first with the regulation of appetite, the homeostatic regulation of appetite, which includes the mechanism after eating the daily food. And among these, we have the gastric satiation mechanism, including gastric distension and gastric emptying, and the gut satiation mechanism, including the secretion of the GI peptides, and finally the microbiome and the interaction between the GI tract and the brain. Let's have a look to the details. We all know that we have different types of cells in our gut. The most abundant ones are the enterocytes, which are responsible for the transport of the nutrients. But then we also have the specialized cells, which only represent 1% of the cells in our gut. And they are special because they do have the taste receptors on their surface, and they respond to nutrients via the activation of these receptors, and we have then the secretion of gastrointestinal satiation peptides, and they signal the information about the food in the gut via the vagus nerve and via the bloodstream to the different organs. So how does such a pattern look like? After eating, within the first minutes, we have an increase of these satiation peptides, and we have already the peak of these peptides after 15 to 30 minutes, and we have a decrease of the only known hunger hormone, ghrelin. What is the side of action? So one side of action of these satiation peptides is that they have a negative feedback mechanism on the stomach. They slow down gastric emptying, and then we have an increase in gastric distension. It is sensed via mechanoreceptors, and in that way, via the nerves, the information is transported to the brain, where we have the feeling of fullness and satiation. On the other side, these peptides have a direct effect on the brain via the bloodstream and the nerves to induce fullness and satiation. What happens in the brain? So in the brain, there are mainly three regions which are responsible for the homeostatic regulation of appetite. We have the brainstem and the hypothalamus. These two mainly process the homeostatic inputs, means the signals from the periphery and especially also from the gut, from these satiation peptides. The hypothalamus also is important to coordinate the central appetite regulation, to say in the end that we are hungry or that we are satisfied. And then we have the reward or hedonic system, which mainly process all the non-homeostatic signals, means the signals from the outside, environmental, social, emotional cues, but also the taste and the olfactory inputs. So this is a very simplified representation of a process which is actually very complex, and therefore it's important to also tell you that a few years ago, and this was a breakthrough in the gut-brain axis research, the group around Hühn showed that there's a critical role for the vagal gut-to-brain axis in motivation reward, which means that the reward or hedonic system not only processes non-homeostatic signals from the outside, but also processes the homeostatic signals from the inside. So in the end, we have these three regions which interact all together and have inputs from the outside and insides from the body. So beside these satiation peptides, we have another player in our body. It's the gut microbiome, which has a number of different functions, but is also important in the regulation of appetite. All the nutrients which are not broken down in the small intestine, they are broken down by or metabolized by the bacteria in the gut, and the resulting short-chain fatty acids, they serve as energy source on the one side, but on the other side, they also have an impact on these specialized EECs and induce the secretion of GI peptides. So together, the homeostatic regulation of appetite, and again, it's a really simplified representation of this complex process. After eating the food, the daily food, we have gastric distension, and as soon as the nutrients are in the intestine, we have the secretion of these satiation peptides. They have a negative feedback mechanism on gastric emptying, an increase in gastric distension, and finally we have another player, the microbiome, and together the information from the GI tract via vagus nerve and bloodstream to the brain, where we have these three centers that are involved in the regulation. So this was the science part, and now it's probably more the fun part and the part which is the chocolate part. So I will present you our chocolate study. The point is that from time to time, Mark is doing studies that give a highlight to a corresponding season. In that way, he did a fondue study during wintertime years ago, and we did a chocolate study during Easter time. I looked it up in 2016. So you have here this, you can scan to the article. But also here, of course, we have a scientific background for this great study. As Thilo already mentioned a lot, so already during time of the Mayas and the Aztecs, the fruit of the cocoa was used as medicine, and still today it claimed to have very positive properties of being stimulant, relaxant, and even antidepressant. So the difference between cocoa and chocolate, Thilo told us, the cocoa is the non-fat component of the finely ground cocoa bean, whereas the chocolate is a combination of different substances, so the cocoa butter, especially the sugar, and a number of other constituents formed into a solid food. The difference now between dark chocolate and white chocolate is that the dark chocolate with this high amount of cocoa contains a lot of positive substances such as the flavonoids, methylxanthines, but also other compounds with antioxidant and prebiotic effect and potentially health-promoting properties. In contrast to that, the white chocolate contains no cocoa and very few biological active substances. So epidemiological studies showed that, or suggested that a regular intake of the dark chocolate has positive effects on metabolic health, including glucose homeostasis, insulin secretion, and is even associated with the reduction in the risk of heart attack, stroke, and dementia. And now, listen carefully. It's a great study, very fun study by the group around Messerly, and it was in the New England Journal of Medicine. You should have a look at it. They were able to show that there is even association between the intake of chocolate per head of population with the likelihood of winning the Nobel Prize. And you see where Switzerland is. So it's the top performer in both, so in the consumption of chocolate and the number of a person who won the Nobel Prize.
That's good. You just need to eat more chocolate. It's not far to go.
It was the chocolate, huh? Okay, the research gaps we have. So we know that dark chocolate has positive effects on GI function and is even used as home remedy for diarrhea, but the objective evidence for the impact of cocoa on this function is lacking. And also we know that chocolate has positive effects on mood, but the central mechanism behind these effects is uncertain. So if dark chocolate has nutraceutical effects on gut and brain, then it could benefit people with GI disorders such as IBS. The hypothesis of our study was that dark chocolate slows GI transit in health and has specific effects on the regional brain activity also in health. What was the design? So it was a prospective counterbalance crossover design. We included 16 healthy participants and randomized it to that they either got first the dark chocolate or the white chocolate, and in between there was a washout of 14 days. In the first 3 days, they received the intervention of 100 grams of dark or white chocolate. It was marked with the capsule for the colonic transit time. On day 4, we they received a chocolate mousse, and after that, we did a PET CT to investigate the brain activity. And then on day 5, it was a scintigraphy part where we were interested in the gastric emptying and OCTT. And all day, 5 days, we asked for stool consistency. More detailed 5 days, because there we received all the output measurements. So the participants ate the mousse, and before and afterwards, every 15 minutes for 120 minutes, we did the scan, and then ask also appetite sensations and GI symptoms. And the outcomes from day 5 was from the scintigraphy, the gastric emptying, and OCTT, and from the marker studies from the capsule where they received all day 1 to 3, the transit time, colonic transit time. We got the stool consistency and appetite sensations. Let's have a look at the results. First of all, I have to tell you that I had a flood of mails and to deal with. We had more than 200 participants that wanted to participate in this study, so I was really had a lot of emails to deal with. And in the end, we included 16 healthy participants. We asked for psychological disorders, GI well-being at the screening, and at the end, not surprising, they were all healthy. So it was at the screening good, and afterwards chocolate did not change this, so it was still good at the end of the study. Palatability, it was no difference between the white and dark chocolate, so they liked it the same. The results for the gastric emptying and OCTT and also appetite sensation, there was no difference between dark and white chocolate. We expected it, as we know that the volume and the energy content is important for these parameters, and that not the substances, the different substances between dark and white chocolate here are so important. But, and this is a very nice result, so what we found is that there was a higher stool consistency and a slower transit time after the dark chocolate in these individuals, and you see it in this slide here. We had a negative correlation between stool consistency and the transit time. And also for the regional brain activity, we observed an increase of the marker. It was fluorodeoxyglucose, an increased uptake of the substance in the visual cortex and prefrontal cortices, and therefore these both regions, which are important for cognitive tasks, and there the dark chocolate has had very positive effects. So let me conclude. The results provide novel evidence concerning the fact of cocoa taken as a dark chocolate on gut and brain. We were able to show that there is a slower transit time and a higher stool consistency after the intake of the dark chocolate compared to the white chocolate. And also the brain imaging showed that there's an increased activity in the visual and prefrontal cortices, important regions for cognitive tasks. We all know that acute and chronic disturbances in bowel function are common, and that the medication we use in the therapy of diarrhea are not always effective, and that many patients ask for natural remedies. And therefore, if the nutraceutical effects of dark chocolate or cocoa-based products are confirmed, it could be a safe and popular alternative to the pharmacological treatment of patients, especially with IBS. So, what did you learn from my talk? Dark chocolate, the secret tip for IBS treatment, and will win you the Nobel Prize. So with that, I would like to thank the Choco team, especially Mark, which was the brain and behind the study, and my team in Basel. So thank you.
Thanks. Thanks very much. So it's white chocolate for constipation and dark chocolate for diarrhea, is that right? Yeah.
Works for everything.
Yeah.
Thanks also from me, Annik. That was excellent. Now I'd like to introduce the last speaker, Dr. Daniel Sifrim. And as I understand, he'll be telling us whether it is possible to eat too much chocolate.
So you got a tough gig.
Good evening. As you know, I am not Philip Woodland. Unfortunately, Philip Woodland couldn't make it, and this was a last-minute change, and he sent me his presentation, and I will present it in his place. So if you don't like anything that I said, it's his fault. The talk is most related to reflux disease and food rather than constipation or IBS. So we know that there are some lifestyle factors that are predisposing to reflux. Smoking modifies the lower esophageal sphincter pressure. Obesity has a clear impact in pressures transdiaphragmatic and also provokes more transient ileus relaxations and favors reflux and even Barrett esophagus. So we know that there are factors that can be very important in the production of reflux disease. So the question is, what happens with the meals and the occurrence of pathological reflux? And we know that large meals provoke a prolonged time to empty the stomach in general, and they increase the number of transient lower esophageal sphincter relaxations and reflux. there is a relationship between the viscosity and the type of material refluxate, but which foods and which drinks are most difficult. We know that the spicy foods, champagne and chocolate and fried foods are the foods that most of the patients are targeting when you ask them what is triggering your symptoms. There is, must say, little evidence of impact of food type on objective reflux measurements. We know that high-fat diet increase reflux. However, a study from Mark Fox showed that in fact it's not the high fat, but the high calories that in fact produce the most increased reflux. There is proof that reduced sugar diet reduces reflux, probably through weight loss, and that the increase in dietary fibers is associated with a reduced risk of reflux. Eating faster results in more reflux, in my opinion, results in more belching related to reflux. Faster eating provokes more aerophagia, and aerophagia is followed by gastric postprandial belching. And finally, late evening meals and going to sleep immediately after the meals is also a factor of supine reflux. Now, what about the chocolate tonight? Are you allowed to eat tonight in the dinner chocolate? The first answer is no, because chocolate has increased caffeine and theobromine, and it reduces LES pressure, and of course it has high fat and high calories. So no. But yes, because there is very little experimental evidence that it connects chocolate to gastroesophageal reflux, and it is very limited indeed. So yes, you can eat tonight unless you personally find that it triggers your symptoms. So the advice of the GP or the gastroenterologist is when the food triggers your symptoms, you need to be careful. In that respect, similarly, alcohol it provokes smooth muscle relaxation and lower esophageal sphincter, lower pressure, and it stimulates gastrin release, and there is some evidence that white wine and beer increase reflux. So tonight we expect to get red wine rather than white wine. And coffee, definitely there are anecdotal reports that exceeded the scientific evidence. Now, in this context, I want to introduce you a consensus study that was undergoing for the last year concerning the management advice for patients with reflux-like symptoms, and this was a Delphi procedure that involved all these people that are written down there. The paper was submitted yesterday, to give you an idea, to Clinical Gastroenterology. And I just wanted to let you know that this paper will come up in the next couple of months. And this is a very large, comprehensive description of the management of lifestyle things in reflux disease, which is, unfortunately, there is very little evidence-based and very little literature about. But this is a compilation of all that. This is just some of the statements that are in that paper. Identification and avoidance of specific dietary triggers should be recommended to individuals with postprandial-like symptoms. I will not go through it. You just will have a large list of consensus-related statements. Other interventions, apart of changing in in diet are also discussed, and all the literature is discussed, and there was a voting and a consensus agreement. For example, the relationship between stress and reflux, diaphragmatic breathing, the use of some medications, not PPI medications like alginates or products containing hyaluronic acid and chondroitin sulfate. I will have to discuss a few things concerning the use of alginates in reflux disease, because I was involved in this research over the years, and Philip Woodland was the main investigator in this topic, and he is presenting some of his results. You know what the acid pocket is a region in the stomach that is not buffered by the meals, and is the mechanism by which we have acid postprandial reflux. For many years, we do not understand how it's possible if the food neutralizes the gastric contents, how it's possible that we have acid reflux immediately after having the stomach full of meals. And the reason is that there is a very localized area immediately below the lower esophageal sphincter or across the diaphragm within the hiatus hernia that is called the acid pocket, and is a region that is not buffered by the meals, and this region is the source of acid postprandial reflux. The effect of alginates in this mechanism of acid pocket is that the alginate cap that region and reduce the possibility of having acid reflux postprandial. But this is not the only mechanism. We have doing some research on that, and we looked at the influence of alginates on the esophageal mucosa, and you can see that the, and you can see this a very thin layer of marked alginates on the top of esophageal mucosa in the biopsies, and it is remaining there for almost 1 hour. So we believe that there is another effect of alginates. We did some studies with taking biopsies and mounting the biopsies in Ascona chambers, and we look at the effect of protecting the mucosa in vitro, and on the left side, this is without any protection. This is a drop in transepithelial resistance detected in a Ascona chamber experiment, and you can see that with pH solution, the mucosa exposed to pH solutions around pH 5, there is a little drop in resistance, whereas solutions at pH 2 provokes a much significant drop in resistance, even more so in patients than in controls. And when we protect the mucosa before the exposure to these solutions, when you do it with a liquid control or a viscous control, there is still a drop in resistance, but when we protect it with alginates, there was a much lower drop in resistance. So we are convinced that there is an effect, a topical effect of alginates and probably other substances in the mucosa of the esophagus. Now, the question is whether this effect happens when you swallow it, and we think that this is not true, because the substance goes through the esophagus in 3, 5, 4, 5, 7 seconds. It's very fast, and it's very unlikely that this is the immediate effect. So probably you need to have the layer of topical protection a much longer time. And how do we know how long it is staying there? This is a very simple experiment that we did in our unit. You know, when you have an impedance tracing and you give a liquid, the impedance drops because of the conductivity of the liquid. So we wanted to know for how long it drops with different solutions. That means how much time the substance is in the mucosa affecting the impedance. So, and you can see the example here. There is we give the liquid, there is a drop in impedance in all the channels, and there is a very slow return to the impedance baseline. And this time is different when you use a viscous slurry, a placebo, or alginate. And you can see that the alginates, it almost 1 hour takes to disappear. So we now know in vivo how long remains the protective effect when you swallow it. Nevertheless, I am not convinced that this is a swallow effect that protects the mucosa, but the other way around. We have an hypothesis, and we have a research project on that. That is that we believe that the alginate refluxes the other way around, that from above the acid pocket, that layer of alginate is going up with every reflux episode. And probably this is the effect that protects the distal esophagus rather than the swallowed material. And we are trying to test that with very sophisticated scintigraphic technique with marked alginates. We know that the PPIs have a very good effect in regurgitation, maybe less than in heartburn and pain. I don't know why Philip chose this ugly black and white slide, but he did it to probably to stress the fact that the PPIs were very powerful in 1995. We didn't know at that time that there was a significant amount of patients that do not respond well. But the point is that what happens when you stop PPIs? And this is a very interesting problem. This is a study that was published in Gastroenterology by a Danish group that tested what happens when you stop the PPIs in a group of healthy subjects. If you see the red line is a placebo treatment, several weeks, and when they stop, nothing happens from the point of view of symptoms. However, in healthy subjects that were taking esomeprazole, when they stopped, they became symptomatic, particularly not of reflux symptoms, but more of dyspeptic symptoms, gastric symptoms. So there is a clear rebound effect in individuals that are taking PPIs in a chronic way. Now, this is another study that was done in London and published this year, where the patients that are going to have a pH metry or an endoscopy, they need to stop the PPIs for 7 days before the test. And in general, most patients complain about that. The day before the test, you ask them how was without the PPIs, and they said that they were having a lot of heartburn or chest pain or whatever. So the question here was, how do they respond if you tell them, okay, you take anything but not PPIs to protect yourself. You take antacids, you change your diet, you do whatever you want to avoid that increase in symptoms, and compare that with a group in which they were prescribed with a fixed formal dose of alginates 1 hour postprandial. And how was the symptom response at 7 days after that? And you can see that the patients that had a control group, they had much more symptoms than during the baseline period where they were on PPIs. In contrast, the patient that had a control, a very clear treatment prescription situation with the alginates did much better. So the point is that in those patients that have to undergo tests that required PPI stop, they can be taking alginates to reduce their suffering, let's say. And so this takes me to the question, what is the comparison between alginates and PPIs in terms of symptoms control? And we now know that it's clear that PPIs control symptoms better than alginates. But alginates control symptoms enough, not to the level of the PPIs, but significantly compared to placebo. And so Philip is asking this and send this point. Do PPIs reduce the chances of lifestyle alteration in patients with mild and moderate disease? And this question is just as follows. If I take a pill half an hour before breakfast every morning that solves my symptoms, that means that I can eat as much as I want, and I can drink as much as I want, and I can smoke as much as I want with one little stupid pill at half an hour before breakfast. The problem is that I have, first, less symptoms. I am entitled to do a disaster with my diet, and that will provoke obesity and other consequences. So the question is if it is the balance between the benefit and the damage is justified. So the idea is that perhaps is a possibility to use something that is not that efficient like the PPIs in a chronic way, that improve your symptoms, but on the other hand, not enough. So you are taking care of your diet. You still have a little bit of heartburn, so you are taking care, you don't eat that much, you don't drink that much, and you don't smoke that much. If it is possible to replace the use of PPIs by a substance like alginate to have a better balance between the control of your symptoms and the overall effect of your diet and in your lifestyle. And this is the aim of the study, is to investigate the initial strategy of alginate plus lifestyle advice is associated to wider health improvement compared to early PPI use. And with this, I will finish Philip's Woodland presentation. Thank him for doing this. And Philip, to those that don't know him, is this one. This is Asen Ustaglu, a PhD student in our department, and this is Chungli. This is our GI physiology in vitro facility. Thank you very much, and enjoy the chocolate dinner.
So this concludes our session on chocolate and health effects of chocolates. I think we're okay eating chocolate. Definitely the dark variety. And so, particularly if we don't have reflux or symptoms. So I assume that we're all okay with that. And so we're basically moving on to this chocolate-themed dinner. So we can having the okay.
Exactly. No, you have the okay. It's kill or cure, but we'll count the survivors at the end of the day. And what I'd also like to do, this is obviously a medical conference, and this event was sponsored by Reckitt, and I'd like to extend my thanks to them for making this possible. And also you will find a certain gesture from Reckitt waiting for you upstairs, just in case you overindulge. So thank you very much for your attention. Thank you very much for being here this evening, and let's all go upstairs and enjoy dinner.